In this learning unit, we will take a look at membrane-type separators. These are a natural development from earlier separators. The membrane itself was introduced as a final stage to improve oil separation. The main principles at work in membrane separators are gravity and coalescing, in addition to the membrane itself, which acts like a filter. Bilge water from the bilge tank is fed to a first stage via a filter. The filter prevents large solid impurities from entering the separator and causing blockages. In the first stage, the bilge water passes through a coalescing filter, where small oil droplets stick to the coalescing mesh. As the small droplets accumulate, they join together, coalesce, and then become buoyant enough to float off to the top of the first stage. From here, they can be discharged to the sludge tank. The second stage typically consists of one or more further stages of filtration, often referred to as polishing filters. These stages are also usually based on gravity and coalescing, but also include membranes that will not allow the passage of oil droplets, so that purities of 5 ppm are claimed by the manufacturers. A process or booster pump forces the water through a filter membrane. The membrane removes any remaining emulsified oils and contaminants. Inside the membrane chamber, the water is split into two parts, clean water and rejected water. The clean water passes through the oil monitoring equipment and overboard. The rejected water is directed back to a de-oiler reservoir, which removes the oil and sends the water through a filter and back to the process pump. The oil is sent back to the inlet side of the oily water separator, from where it will be discharged to the sludge tank. What is the purpose of the filter fitted to the inlet of most bilge separators? Select the one best answer. Bilge water separators using chemical flocculation are claimed to be the most efficient and are one of the most popular types, so pay special attention to this learning unit. As we have said, flocculation is a process in which two or more particles aggregate, stick together. In the well-known Marin-Floc AB system, we help the flocculation process along by adding a flocculating agent, such as polyaluminium chloride, to the bilge water. Particles are then bound together through chemical action. This process will form particles larger than 100 nanometers, and these particles, called flocs, will then be able to settle. This works best at a pH of between 6 and 8. Let's take a look at the different stages of separation in a flocculation-type bilge separator. Bilge water from the bilge tank is fed to the first stage via a filter. In the oil separator, the bilge water circulates upwards around the periphery of the separator. The change of direction and drag helps to separate the oil from the water. Free oil collects at the top of the separator, from where it will be transferred to the sludge tank. The water then goes downwards through a pipe in the center of the separator. In the bottom of the pipe, there are baffle plates to separate small oil droplets from the bilge water. After the oil separator, the bilge water goes through a circulation pump and into an aeration chamber where the water will be mixed with air. After the air-water mixing tank, the flocculation agent is dosed into the aerated bilge water. This will start the flocculation process, forming particles larger than 100 nanometers. When the aerated bilge water reaches the flocculation tank, the flocculation process starts. Due to all the air in the water, the flocs will float through a pipe in the center, to the top of the tank, where they are skimmed off and transferred to the sludge tank. Flocs mixed with sludge can then be incinerated. The partially treated bilge water now passes to the polishing filters. To ensure a constant ppm value well under 15 ppm, there are 3 filters fitted in line before the bilge alarm. The first stage is filled with a coarse sand filtering medium, aqualite mineral, and the next 2 stages are filled with active carbon. The clean water leaving the polishing filters can then be discharged via the separator discharge monitoring equipment, an automatic stop and recirculating valve. Used correctly, a discharge of 0 to 5 ppm can be obtained. Drag the correct words to their correct place to complete the following statement. In this learning unit, you will learn that the accuracy of the oil content monitor is highly important. You will also be able to identify the common working principles of an oil content monitor and the factors which may affect its accuracy. There are 2 reasons we need to know about this. Firstly, it will help ensure that we do not pollute the seas. Secondly, it helps provide assurance that we are not breaking the law. At this point, let's mention that in the past, a few individuals have tried to deliberately fool oil content monitoring systems by making illegal connections. Others have deliberately bypassed separating equipment altogether, with arrangements that have been referred to as the magic pipe. Such arrangements are illegal and immoral and have led to prosecutions, jail sentences, and heavy fines. The oil content monitor will have anti-tamper seals to prevent you altering things that you shouldn't be altering. A 15 ppm bilge alarm must be accurate to within plus or minus 5 ppm, and it must keep this accuracy even if there are other contaminants. The accuracy of the 15 ppm bilge alarms should be checked at the IOPP certificate renewal surveys in accordance with the manufacturer's instructions. These accuracy checks can only be done by the manufacturer or persons authorized by the manufacturer. On board the ship, you can re-zero the instrument, but IMO guidelines require that the alarm is activated whenever you use clean water for cleaning or zeroing purposes, which will in turn close the overboard discharge valve. Some manufacturers provide a facility for checking but not adjusting calibration without breaking seals or making illegal adjustments. But you need to check the manufacturer's information carefully before doing this. Many of the ways of measuring oil content are based on optical methods. including infrared and ultraviolet light absorption, fluorescence, and light scattering. Light absorption measurements are made by passing a beam of light through the treated bilge water and measuring the attenuation, reduction in strength, of the light beam. The degree of light scattering, fluorescence or absorption varies between types of oil and droplet size. Fouling of the optical surfaces can affect the readings. Contaminants other than oil may be present, and different types of oil may be present. Fluorescent types are said to be immune to interference by turbidity or particles in the sample, because silt, algae, iron oxide, and so on do not fluoresce at the same wavelength as oil. However, we should keep in mind that this means that fluorescence types may not detect water contaminated with things other than oil. Most types of detection will be sensitive to the water temperature, but some form of compensation for temperature is usually built into the sensor. The 15 ppm bilge alarm should record date, time and alarm status, and operating status of the 15 ppm bilge separator. The recording device should also store data for at least 18 months and should be able to display or print a protocol for official inspections as required. In the event the 15 ppm bilge alarm is replaced, means should be provided to ensure the data recorded remains available on board for 18 months. According to IMO requirements, what should happen when using a separate clean water supply to zero the 15 ppm bilge monitor? Select the one correct answer. This learning unit discusses the Marinfloc IMO white box system. The white box system was designed to protect you, the rest of the crew, and the ship owner, so you should learn more about it. The white box system was developed by the company Marinfloc as a fail-safe system for the discharge of water overboard. It is intended to prevent water with too high an oil content being accidentally pumped overboard. It can function as an ODME system as required for tankers, but may also be fitted on other types of vessel. To help prevent tampering with bilge separator overboard and monitoring arrangements. All of the equipment is built into a lockable cabinet, given the name the white box. This helps to protect the crew and ship owner, because it provides the evidence that operations have been legal, and that there has been no tampering with the equipment. The white box system can be placed between any type of bilge water separator and the overboard discharge, and consists of a pressure control valve, a ppm monitor, a flow control device, an electro-pneumatic three-way valve, a flow meter, and a recorder. The treated water from the bilge separator is fed into the white box. The three-way valve will be in the recirculation position until the oil content meter and flow control device instruct the valve to open for discharge overboard. What is the main purpose of the so-called white box system fitted with some bilge separators? Select the one correct answer. The main principles at work in membrane separators are gravity and coalescing, in addition to the membrane itself, which acts like a filter. The separation process in a membrane-type bilge separator takes the following steps. Step 1. In the first stage, the bilge water passes through a coalescing filter where small oil droplets stick to the coalescing mesh. Step 2. Filtration through polishing filters, including membranes that do not allow the passage of oil droplets. Clean water passes through the oil monitoring equipment and goes overboard. Flocculation is a process by which two or more particles aggregate, stick together, without losing their individual boundaries. We help the flocculation process along by adding a flocculating agent. This process will form particles larger than 100 nanometers, and these particles, called flocks, will then be able to settle. This works best at a pH of between 6 and 8. Stages of separation in a flocculation-type bilge separator. Step 1 is oil separation. In Step 2, the water goes through a circulation pump and into an aeration chamber, where the water will be mixed with air. In Step 3, the flocculation process is started. Step 4 is processing of the flocks. The flocks float through a pipe in the center to the top of the tank, where they are skimmed off. Step 5 is filtration through 3 inline filters. And finally, Step 6 is overboard discharge, with a ppm of 0 to 5. Accurate monitoring of the water we are discharging into the seas is important due to environmental and legal reasons. Practices like the magic pipe are immoral and illegal. They have led to prosecutions, jail sentences, and heavy fines. A 15 ppm bilge alarm must be accurate to within plus or minus 5 ppm. An alarm should activate and the overboard discharge valve should close whenever you use clean water for cleaning or zeroing purposes. Oil content measurement is often done by optical methods, including infrared and ultraviolet light absorption, fluorescence, and light scattering. The accuracy of oil content monitors is affected by the type of oil and droplet size. Fouling of the optical surfaces can affect the readings. Contaminants other than oil may be present, and different types of oil may be present. A 15 ppm bilge monitor should record date, time, and alarm status and operating status of the separator. Data should be stored for at least 18 months. As soon as the three-way valve opens for discharge overboard, the recorder starts. The recorder gives the following information: the time of when the overboard pumping started, the oil content meter level over a discharge cycle, the total quantity of water pumped overboard in a discharge cycle, and the time when the overboard pumping stopped. The white box system can be interfaced to the ship's navigation system to record the ship's position and course for the time that bilge water was pumped overboard. The IMO white box is a fail-safe system for the discharge of water overboard. It is intended to prevent water with too high an oil content being accidentally pumped overboard. It can function as an ODME system as required for tankers, or can be fitted to monitor machinery space bilge water on all types of vessels. All the equipment is built into a lockable cabinet, given the name the white box. The white box helps to protect the crew and ship owner by providing evidence that operations have been legal and that there has been no tampering with the equipment.